Today, we are going to discuss the SAR analysis capabilities in ICM or particularly ICM Chemist Pro. First, we will import a dataset which has the COX-2 inhibitors along with its activity in SDF file format. Now, once we import it, we will see that the structures are there along with the activities. Now, we will draw the scaffold. In ICM, we have the option to draw the scaffold by using the inbuilt editor, or we can import a scaffold if it is already there. In this case, we will draw the scaffold and save it as a table. Next, we will go to chemistry, SAR analysis, R group decomposition. In this, we will select the COX-2 inhibitors as the table for decomposition, and then we will choose the table with scaffold for decomposition that we have already drawn. After that, we will click on OK. As soon as we click OK, we will see that we have the decomposition table with R1, R2, R3 and R4 along with the molecule and the scaffold being highlighted in green color. Then we will choose to plot this data. Now we will plot R1 versus R3. In this case, you will see the R1 versus R3 plot. Now, if we want to put the activities into the picture, we will color the plot along with the activity. Now in this case, you can see that the activities are plotted. Once you select it in the plot, it is automatically selected in the R group decomposition table. Now if you want to see the structures in the plot itself, then what we can do is we can create the molecule cards. So once you create the molecule cards, you will be able to see the molecules for the selected points. You can increase or decrease the size of the molecular cards, and you can have multiple molecular cards in view. So this gives a very good and easy way of visual analysis of the SAR of R1 versus R3. We can also increase or decrease the R1 versus R3 plot channels. In this cases, both the axes can be increased or decreased, zoomed in and zoomed out. Now, once we are done with that, we will move on to the next one, which is SAR analysis and free Wilson analysis. In this free Wilson regression analysis, we will use the decomposed table and we will perform the enumeration and prediction step. In this, basically, there are weights that are assigned to each of the R groups, and that shows the contribution of this particular R group in the overall activity. The color coding shows the positive contribution or the negative contribution. Blue represents a positive contribution, whereas the red represents a negative contribution towards the activity. You can see for all the R groups that were there, it has been created. Next, we will go to the SAR analysis table, generate the SAR table. So in this case, we will again select the same decomposed table. We can select R1 versus R3, or we can calculate the pair automatically. If we want to select it manually, we can do that. In this case, we will do R1 versus R3 and we will plot it. In the SAR table, you will see that we have the scaffold and the functional groups over here. Now we will also see that there are the molecules that can be comprised or composed using these functional groups along with the scaffold. Now once we click on this, we'll automatically see that this structures or this table is dynamically linked with the decomposition table that we had done earlier for the free Wilson analysis, regression analysis. So once we click on these structures over here, it will automatically take us to the same structure with the decomposition table with the free Wilson regression analysis. After the SAR table, we will go into generating the SALI table. The SALI table and the match molecular pairs are generally used to identify activity clips. So in this case, we will select the decomposed table, and after we click OK, we will see that it has created pairs of molecules and a plot of activity 1 versus activity 2. Now in this case, you will see there are two molecules and both the structures are visible along with their IDs, and then there will be a SALI score. With the higher the score, the better it is in terms of the more is the effect in activity by a change in the structure. So you can see activity 1 and activity 2 are also shown over here. Now in this case, if you select a point in the plot, we will see that that particular pair gets selected. If you look at the color coding on the plot, red means that a small change in functional group makes a large change in the activity, whereas the blue one means a small change in functional group does not make that big a change in the activity. We will move into the next one and the last one in this series, the matched pair analysis. For that, we will go into the SAR analysis and matched pair analysis. We will use the COX-2 inhibitor SDF as the input, and you'll see that we have molecule 1. We also have the second molecule along with its ID, and we have these R groups. So these R groups are basically the groups that are changing. So over here we will see the activities are also there. So in first molecule, hydrogen is the one that is there in the R group. In the second one, it is the carbon. So if you see the D activity, that is the difference in activity between activity 1 and activity 2, and then there is a score which is 1.875 for the first one, which is the matched pair analysis score. Now we can see the scaffold as a structure converted from smile. Now in this you will see that there are the R1s where these displacements happen, which causes a change in the activity. Okay. Thank you all for watching. I hope I will see you again in the next video.